Okay, right, hello, welcome back to another video. So today we're going to be talking about collisions, how to make objects collide with other objects, how we can control that with different channels, how we can do that with particles, and then how we can all set that up and edit it in the engine. So start just with a simple sphere. If I want this to fall under gravity, I can just turn on simulate physics, and then when I simulate it will do that, it will fall and hit the ground. If I wanted to keep this location as the default location, I can right click, keep simulation changes, and now when I stop, it will take that as a default. But remember, it is still simulating physics. So if you want it to be a static object now, you just disable that and it'll go back to being static. But that's not what we're here to talk about. So simulate physics falls down under gravity. If I make two objects, and let's just copy that down. In fact, let's just copy it straight down. You'll see we get, unfortunately, a bit of a fake error here. That's not very realistic. If we just take one of our objects and give it a little bit of offset, now we should get something a little bit better, where these two objects will fall a bit more naturally. Okay, so two objects falling down under gravity and they're colliding with each other and the floor. Let's say I wanted this object to not collide though. Well, if we go to our collision settings, by default, the collision presets have been set by the simulate physics option. If I turn this off, the preset now is set to block all dynamic. If I turn it on, it's set to physics actor. I believe when we create a new object, the default is just set to default. So depending what we're doing with our simulate physics, it will automatically set that for us. But we can also overwrite it, no problem. So what's happening? Well, this object here, well, every object has a type. If I open up my collision presets, if I change this from physics actor to custom, it'll keep all the settings for physics actor, but allow me to edit them. So every object has a type. These both are of type physics body. And then within that type, it has, or within that object, it has how it's going to interact with other objects of the same type and other types. So here are all the types down here. So physics body is one of them. Excuse me. World static, world dynamic, pawn, vehicle destructible, projectile, and then this one which I've created, small physics object. So if this is a physics body and this is a physics body and this one is set to block physics bodies, they will collide. And they do. If I select this one and set it to ignore physics bodies, then they will pass through each other. Now that doesn't matter whether this is set to simulate or not. As long as it's set to ignore physics bodies, it will ignore them. Now it's still colliding with the floor because the floor is of a different type. It's of using the default collision settings, which is of type world static. So you can have objects that collide with some objects but not others. And you might ask, why would we want to do that? Well, the reason is basically performance. If you're having a big explosion and you're firing out hundreds of small little physics actors, the really small ones, they want to collide with big things, but they don't want to collide with each other. They don't want to collide with every little tiny piece of geometry in the world. It would be great if they could, but it would probably be too expensive. And so what you might want to do is have some really big collision blockers. If you've got the front of a building, maybe it's just a box or a plane, and then all things like little window jams and door handles and all stuff like that. We don't need to worry about that in the physics simulation. It's a big explosion. There's lots of stuff happening. There's screen shake and audio. We can get away with our collision objects just bouncing off the front of the building just a sort of a plane or a box. And so there's lots of performance reasons why you might want to kind of control your physics collisions. Cool. So if I set this one back to block and I set the top one here, this is simulating physics. I can set this one to custom and this one to ignore physics body. And so if either of them are set to ignore, the collision won't happen. The only way you get collisions is when both objects are set to be colliding with the other object. So if either of them are set to ignore, it won't happen. Cool. That's physics objects. That's ignore and block. Block will make a collision, ignore won't. What about this other one though? We have overlap. Well, overlap, if I turn it on, and let's do it on, doesn't really matter, on either, it will still not collide. So overlap is also not going to create physics collisions, but it does allow us to have events. And so we can use this to create a trigger event. So as this passes through this, maybe we want it to destroy the small object or the other object, maybe we want to spawn some particles, maybe some gameplay happens, but we can create effectively a collision box or a trigger based on this physics collision happening, or physics overlap happening, I should say. So let's set this up so that the bottom one is set to overlap, the top one is set to block. And I'm going to create an event when this happens. So in the level blueprint, with my object selected that is set to overlap, I can add an event. And there's 3 collision events you can have here. Begin overlap, that's when the collision first happens. End overlap is when it stops happening. And then actor hit, so that's when a physics hit happens, so the collision happens between the two. We're going to do begin overlap. And we're not going to go in and make sparks and destruction and all sorts of things that we could do. Instead, we're just going to print string and just print a quick hello to the screen. Okay, compile that and save that, and nothing happens. Why not? Well, as well as having the collision response set to overlap, we also need to have the generate overlap events enabled. Now this needs to be enabled on both objects. If it is, now we should get hello. Not sure if you can see that in the screen, it's a bit small. I don't know, can I change the font size? I don't think I can, no. Okay, well, if you can't see it, you might have to take my word for it. If we go to the window, is it message log? No, output log. Should, oh, there we go, print user messages, hello. That's probably a bit small to see as well, but there we are. It is definitely doing it. We have set it to overlap, so we're generating an overlap event, and we're picking that up in Blueprint here to do just a quick print screen, print string to screen. Cool. So that's the 3 responses. Block will create collisions, ignore will do nothing, and overlap will not collide but will generate events, and so you can do kind of logic and physics and gameplay and stuff on that. Okay, that's all the options for sort of solid physicsy objects. What about particles? Well, if I just create a brand new sphere, and then in my project folder, I have a collision. Let's just make a new one. I've already edited that one. So we'll start just with a fountain template. And bring that into the world. And a couple of things I'm just going to edit about this. Firstly, one thing that really annoys me is when a particle has a direction to it and that direction doesn't follow along the axis in the icon. So in add velocity, I'm going to change this to the x-axis. Now that makes more sense. And I'm going to point it downwards, and I'm just going to set the velocity down a bit less so that they're sort of falling. Okay, so by default particles do not collide. Particle collisions can be quite expensive, so you don't just want it on for everything everywhere, and depending on what it is, it maybe wouldn't make sense anyway. If it's like smoke doesn't really collide, so so by default it doesn't happen, but we can enable it. So in particle update, I'm going to add a collision module. Now this is a CPU emitter because we haven't changed it to not be, and so we're using CPU collisions. So it's a little ray trace. So every particle is checking forwards. Am I going to hit something? If I am, where and when and how and what angle am I going to bounce off at? And we can set all the change all the settings for that here. Because we're using CPU collisions, if I scroll right down to the bottom, we're actually using the same physics system as the physics objects that we just saw. And so CPU collision trace, we are a type world dynamic. So this particle system here is a world dynamic. This object has a collision response. Collision preset, if I change this to custom, is of type world static. And how does it respond to world dynamic? If I said ignore, now it's just going to pass right through. So if we're using CPU collisions, which are a little bit expensive, we can control that via the collision channels of our object. Note, we can't do full physics simulations, so we can't have the particles adding a little bit of mass and pushing things around. That unfortunately is not how the system works. You could build something that did that, but you'd have to do it through events and all sorts of things. So although it says simulate physics and you can give particles mass, I don't believe, unless I'm very wrong, you can actually do this as like it will do a full physicsy calculation, and so kind of like impart mass and push things around. Cool. So we can ignore particles. We also can't generate overlap events with particles. That's not going to give us the right result, or give us any result. Overlaps are only going to be between two physics objects. Cool. So that's CPU particles. As I say, not always the cheapest, or not very cheap at all. So generally not something we use. But if we change this to GPU particles, now the collisions we're getting here aren't collisions based on the physics system. By default, we're using depth buffer collisions. And so if I have a look at the depth buffer, or the scene depth, I should say, the sphere is written to depth. The particles are picking up that depth and then saying, well, if I'm going to collide here, if I would move from sort of one side of the object to the other, I'm going to collide, and then you can create bounces off and collisions that way. But because we know we're using the scene depth to create collisions, we could take this object and stop it writing to scene depth. Easiest way to do that is to apply a transparent material. If I just put this back to, oops, not that one, default. I have a transparent material here. If I just apply that to my object, notice it renders slightly different, even using an expensive translucence blend mode. So this is set to translucent and surface translucency volume, which is the expensive translucent blend mode that gets normals and roughness and things. Even using that, we're going to get a slight difference in the material. Maybe we'll just do that again so you can see that's opaque, and you can see where the sort of shadow line comes. Whereas if I change this to translucent, apply it to this object, it renders reasonably realistically, but yeah, much more expensive, but no longer collides because we're not writing the object into the depth buffer anymore. There are other limitations. We're no longer getting shadows. You can set up lights to do translucent shadows, but that's quite expensive, and the actual renderer as well, the shader we're using here, is quite a lot more expensive. So there are definitely some limitations to this, but now we have cheap particle collisions based on depth buffer. We have objects that don't write to depth, and so they ignore the collisions. Better way to do this, probably a better way to do this, is we have another option for particle collisions on GPU. Rather than depth buffer, we can do distance fields. This will now apply our collisions based on the distance field. Translucent objects won't be writing to the distance field, but if I put this back to the default material, there we are, our collisions come back. Our rendering is good and our shader isn't expensive, but we can also turn off distance field lighting. So affect distance field lighting. If I turn that off, it no longer writes to the distance field. If I visualize global distance field, you can see it's not writing there, and now it is. And so you can tell specific objects not to write to the distance field, and therefore not to be affected by distance field collisions for your particles. Again, this will have some knock-on effects. It will no longer be writing distance field lighting, so it might affect the quality of your lighting, but you just have to decide which is the feature you want and the limitation that you're happy to live with. Okay, so we've done physics objects and how they collide using different object collision channels, so overlap, ignore, and block. We've done particles. There's one more type of collision settings, and if I just grab a couple of spheres here, the other option we have here in collisions is the trace responses. So we've looked at object responses. Trace responses work with line traces. And so let's jump over to Blueprint again. And then I'm going to select my top object and create a reference. And I'm going to do event tick, just as a quick test. And I'm going to do a line trace by channel. So what I'm going to do is just draw a line from this object straight down and see what I hit. And so I'm going to get the actor position, actor location as the start of my line trace. I'm going to add -1000 in Z for the end. And then this is actually going to hit itself, so I need to set actors to ignore and just ignore the object. Okay. So turn on the debug for 1 frame, just compile and save that. What we should find is our line trace is cast down from the sphere. The first part is red because no hit has happened. The hit happens, then we get a little red square, and then the rest of it is green, saying that this is not tracing anymore. A trace has already occurred. But the trace response, the trace channel that we're looking for here is visibility. If I select this object, go down to my physics settings, trace response, visibility, I can set it to ignore. And now that line trace will hit the floor, but not this object. And so you can control your traces and whether they collide and whether they hit and whether they don't by using the same setup here. Cool. One last thing, how do we add more of these and control them? The engine comes with some. If we go to engine collision in project settings, the engine comes with some default ones, so world static, world dynamic, those kinds of things are coded in. But we can add our own. They can have up to 18 custom channels for traces or objects. So there you can see all the different ones there. So projectile was added automatically when I created this using the first person template or third person template, whichever one it is, maybe both. I think they both have projectiles, but it's not an engine default because your game maybe doesn't have projectiles. This one I've created here, I can just delete and create a new one. And so that window's not the right size, not very helpful. Yeah, so we talked about physics objects earlier, small physics object. And I'm going to set this to be ignore, accept. So the default response is ignore. So small physics objects will be spawned, be affected by physics. They will be affected by gravity. We can create some things that collide with them, but we don't want every little tiny collision object colliding with every little piece of geometry in the world. It would be lovely if we could. It's just not very realistic for real time. So that's the way we can add more, and we can do the same obviously with trace channels and all sorts. Cool. It does get quite complex. There's a lot going on. Every object has its own settings. Every other object has settings. You have to kind of make sure that everything is correct and talks to each other. It's very easy to create bugs and these kinds of things. But it's also very powerful. Allows us to have full control over what is interacting with what. So object responses, how do physics objects interact with each other? Do they ignore, overlap, or block? Overlap generating events. Particles, how do they work? If it's CPU particles, then basically it's the same. It's just a collision channel. If it's depth buffer, we have to turn our objects to not write to depth by making them translucent, which can be a bit expensive and has its own issues. Or we can use GPU distance fields and just tell our object not to write to distance fields, and then it will. Oh, that's not the right one. Where's distance field lighting? Affect distance field lighting, and then it will just pass straight through. And so we can have particle collisions that collide with some things and not others, which is quite a nice way of working. So if you want to learn more about Niagara, materials, blueprints, all sorts of Unreal stuff, do check out my longer form tutorials over on Gumroad and Udemy. Currently working on some really advanced Niagara stuff, so check that out when it comes out soon. As always, big thanks to my patrons for supporting the channel. If you do have any questions about materials, tech art, Niagara, blueprints, anything like that, do reach out. I'm always happy to check a quick video together if it's something that's sort of an interesting problem and I think will help people. But yeah, do have a play with collision channels. You can do some cool, interesting stuff and save some performance, which is probably the most important thing. So All right. Hopefully that was helpful, and I will see you all next time.